Hello, everyone. What I want to do is go over homework 8. The scores were a little better than usual. Median and average were about a B. But yeah, let's go over this. So, yeah, most people got the first problem correctly, which I was very happy about. Take out a 30-year, $300,000 mortgage, constant payments at the end of each month, and interest rate of I-12 equals 6%. So before I do anything else, let's just figure out what these constant payments are. Call them K. 300,000 is the present value. It's the mortgage amount. So it's K. A. So 30 years of months is 360. 30 times 12. 360 payments. 0.06 over 12 is 0.005. With 0.5%. So clear TPM, 300,000 present value, 0.5% interest, 360N, compute payment. And we get K is 1,798 65 cents. Okay, so after 20 years, you refinance the mortgage with a 10-year mortgage. With interest rate, I-12 is 3%, but pay a penalty of 5% of your outstanding balance at this time. Find the difference in payments between the monthly payments in the first 20 years and the last 10 years. All right, so we need, if we want to refinance, we got to figure out the outstanding balance after 10 years. So that's 120 months. Finding outstanding balance after 20 years. So it's 240 months. Okay. All right, so constant payments for this mortgage. So we can use our slightly easier, quicker formula. 1,798,65158. N minus T is 240, N is 360. So that's 120.005, 0.5% effective interest rate, effective monthly interest rate. All right, so clear TVM. Let's make this the payment. 120 N 0.5 interest, compute present value $162,010 and 76 cents. All right, so you pay a 5% penalty. So just times this by 1.05. I'm not going to write it, but you just take this. There's a 5% penalty on your outstanding balance after 2 years. So just times 1.05. You can take 5% of this. That's your penalty plus this. Same thing as 1.05 times this. So it's 170. I'll have it right down. 170, 111, 2967. All right, so finally, we're paying this off with constant payments for 10 years. Payments are at the end of each month. So 170, 111, 2967, KA 120. I-12 is 3% now, so 0.03 over 12 is 0.0025. Right, so this is already in the calculator on the screen. So set this to be present value. 120 and 0.25 interest. So 1642 and 60 cents. Sorry, 61 cents. That really matters, but all right, so we should just subtract the two. So you just take the 1798.65 minus 1642.61, a difference of 156.04. All right. So for the next problem, I do want to remind everybody, I don't know why I have to remind everybody, but we do have a formula for paying a percentage of interest at the end of each year. Okay? So we have a $120,000 loan, and we want to we pay off interest, 150% of interest for the first 12 years. Then for the next 8 years, pay off the loan by making constant payments of K at an interest rate of 4%. So for the first 12 years, it's 5%. Find K. So, right. So the formula is just in one of the videos. It's a very easy formula. No reason not to use it. So it's 1 plus your interest rate plus, so it's P times 100%. So it's 1.5 times 100% here. So, sorry, it's minus, not plus. So it's minus 1.5 times my interest rate to the T, which is 12 here. So that's going to be 120,000. Some people made a table. So they correctly said, well, all right, so what's the interest in the first year? 120,000 times 0.05 is 6,000. So if we're paying, actually, people made a table. I think they made a table for both, actually. So sorry. So you pay 150% of this times 1.5. It's 9,000. Well, sure, but you're not just taking 9,000, subtracting it from the 120,000. You have to pay. This is your total payment. So you have to pay off interest first, and then what's left goes towards the principal. People also did that for 3, and I'm pretty harsh if you did that because it means you don't understand how loans work, and that's really super important. Anyway, back to doing it this way. I think one person actually did make a correct table doing it year by year, which is not efficient. If I had said 50 years and I had you want to find out setting balance after 40 years, you're really gonna compute things 40 times. Probably not. And if you're going to do it that way, I want to see all of your work. Probably be a little harsher on the exam than on the homework if you do that. Anyway, you get 88,559 and 20 cents. So all we're doing now is paying this amount off by yearly constant payments at an interest rate of 4%. So there's 8 years left. And just plop into your calculator, just like I did before. Get 13,153 and 60 cents. All right, so yeah, similar problem here. People did kind of the same thing I was talking about before. So you have a $10,000 loan, 7%. You pay this back by paying 300% of each year's interest. And at the end of each year, when does the outstanding balance first fall below 2,000? So what some people did was they said, okay, 10,000. Oops, sorry, this is blocked. So the interest So the first year is $700. 300% of that, well, times 3 is 2,100. And then they said, okay, well, your new outstanding balance is just take 10,000 minus 2,100. And again, that was pretty harsh if you did that because, well, that, what about interest? You got to pay off the interest. Computed the interest. You can't just not pay off interest. I mean, I guess you can if you really don't want to, and then, you'll have a lien on your house and the bank will take it over, and that's not good. You'll get kicked out of your house or default on your student loan payments, and bad things will happen. That's to declare bankruptcy. You want to pay interest if you're going to take out a loan. Anyway, so just like I did in one of the videos, again, for some reason people don't want to use this formula. I mean, I guess they don't want. I don't know. I have a feeling people are not watching the videos. And if you don't watch the video, well, obviously you're not going to do well on the homeworks. But anyway, so 2000 is so the way we do this, we set up 2000 is OBT. So we solve for t when we have 2000, and then round up to the nearest integer. And we can check our answer, no problem there. So the formula is 10,000. Again, it's 1 plus your interest rate plus 300% is 3 times 100%. So this is my P in the formula. So it's your interest rate. I keep putting a plus here, the minus. So again, someone did this correctly by hand. That wasn't too harsh if you did that correctly by hand. But if I had instead, the answer would be like 100. Again, you're really going to do 100 calculations. It's not the point of this course. Anyway, so you solve for t 10.67. So your answer is 11. And you can check. Keep plugging in t. If you really want to, you could check your answer. Plug in 1, 2, 3, 4, 5, 6, all the way to 10. I'll just do 10 to do 0.86. 10. Let's do 10 times 10,000. We're close to 2,000, $2,200 and $13. Well, if we do 11, let's just multiply this by 0.86. That's going to give us 10,000 times 0.86 to the 11. And we're just below by about $97. We're below 2,000. So this is the first time you're below 2,000. All right, last but not least, always when I teach this course, people confuse constant principal with constant payment. Okay? Remember, payments on your loans involve interest and principal. You first pay off your interest, then you pay off your principal by what's left. Here we're saying I'm designing payments so that I'm paying constant principal of 1,000 at the end of each year. Okay. So you do that, you're still paying off your interest, and because your principal decreases each year, your interest decreases also each year. You're paying interest on less and less and less principal, so that your total payments, principal of 1,000 plus interest payments, decreases. Okay? It's not your job to figure out in a clever way what the payments are. I gave you and I derived, I forget how much detail I derived the formula, but I give you the formula. So this is constant principal, not payment, not constant payment. I'm putting 5 exclamation marks because people always do this. They always mix the two up. Don't be that person. So the formula is K. Yeah, this is a formula I had in one of the videos. Makes me question if people watch the videos. But anyway, 20,000 over 20. It's the loan amount over N, which is 20, plus the interest rate times the loan amount, 20,000, minus the loan amount over N times T. All right, and you simplify this to 1,000 plus 600 minus 30T. So there's really 2 ways to do this. It's a summer course, so I didn't really go over the other way to do it. One person did do it correctly. I was fine, happy to see that. You can leave it like this, like I do in the video, or you can say this is 1,600 minus 30T. So here you would have a constant annuity minus an increasing annuity. If you do it this way, you have a constant annuity plus a decreasing annuity. I don't know if one's any harder than the other, but I don't really feel like changing the video just to do it another way. But now when I teach it, I do it both ways, honestly, during the regular semester. All right, so K1 T equals 0 is 1,600. K2 T equals 1, 570. K3 T equals 2, 540. So the pattern right, so this is 1,600. So remember the way I did in the video is not this way. Sorry about that. You keep the 1,000 plus T equals 0, 600. This is 1,000 plus T equals 1, 570. 1,000 plus 540, etc. K20 T equals 19. It's going to be 1,000 plus 30. If you had K19, I guess I probably should do that too. T equals 18. You're going to get 1,000 plus 60. So the point is it's 30. It's decreasing. So it's decreasing by 30 each year. 60, 57, 600, 570, 540, all the way down to 60, then 30. Okay. So let me fix this. A little weird. So 19, 30. No, that's right. 60 and 30. Okay, so right. So it's so accumulated value. So these payments are deposited into account earning 4% interest. Okay. Find the accumulated value. So it's 1,000 S20.04 plus 30 DS 20.04. And remember, this here is 30 times 20, 1.04 to the 20 minus S 20.04 over 0.0. All right, so you're gonna get first one is 29,778 and 8 cents. It's a very messy 7. A little better looking. And the next one you dump into your calculator, 10,533 29. for a grand total of 40,311.37. I wrote that backwards. All right, so hopefully that makes sense. Yeah, remember one last homework 9 on bonds, and that's the course. There's more if you want to watch. You might want to watch the videos on internal rate of return and net present value, particularly because, if I might say so myself, I think I have one of the clearest explanations out there of practical meaning of net present value, of internal rate of return, and the practical idea of the concept of why you should always, or why do people say always do a project if net present value is positive. I totally explain in one of my videos why that's true. I just explain what the very practical meaning of net present value and internal rate of return is, and other similar stuff. Anyway, I mean, if not, you'll see these in other courses. If you're an economics business major, actuary major. If you're neither, you probably won't, but very practical business stuff. All right, anyway, let me know if any questions. The exam will be due Monday. I'll have it up Friday. Homework is due Friday, and that's that. No extra credit, but I will drop one homework. Again, any questions, let me know. All right, so long. Take care. Bye-bye.